We now consider an illustrative example for two-stage cluster sampling. Consider a finite population of households in a city. The city consists of capital Ni clusters of houses. This is and the cluster I consists of say 50 houses. We use the following two-stage cluster sampling. So first we select Ni sample clusters. So here we just use 3 simple random sampling, and then within each selected cluster I select m equal 4 sample houses by the simple random sampling. This is a typical case for your household surveys. The city is decomposed into many blocks, which is clusters of similar sizes, and the sampling of the houses are done in 2 stages as above. Once the sample households are selected, then we obtain 2 information. One is the number of household members, so X, and the other one is the number of household members with the age under 6, or something like that. Okay, so the following table gives a summary of the realized sample household from the above 2-stage sampling. So this is the number of household members, right? Members. And this is number of household members less than age less than 6 or equal to 6, something like that. Okay. Here we are interested in estimating the proportion of the population with age under 6 in this city. So the parameter of interest is actually the ratio, right? So total number of people with age less than 6 divided by total number of people, population size. So in this case, this is essentially a ratio, and a total estimator. The proportion estimator is total estimator ratio of the 2 total estimators, right? And then for variance estimation, this is really so this is what we did before. We have something similar in homework already, but let me just repeat. So if you do Taylor expansion, then this is your p x hat x t hat x, right? Okay, and then variance of p hat is 1 over tx square variance of t hat y minus p times t hat x. So that is, you can write it as a t hat d, where t hat d is the total of the difference. So that is actually Ni m times d bar I, and d bar I is 1 over m j equal to 1 over m dij, and dij is yij minus p xij. Okay. So then using the simplified variance formula in page 15. So this is the simplified variance formula. So we can basically, so what is the variance formula for t hat d? Well, that's basically this one. So here t hat, this t hat is what? T hat is, here is t hat equals Ni over Ni, I equal some sample of clusters of the Ti hat. Okay. And now T hat T is simply m times d bar. Okay, so you can basically apply, you can use this. So, right, because if you compare these two, this is this. So you can apply formula. So what is st? St is just ni minus 1 summation of ji equal to 1 to ni, I mean the sample, cluster sample, and then ti hat minus t bar, right? So now you can basically put this here and apply. Then you should be able to, but the problem is that di bar is y bar I minus p x bar, and and you don't know this, so you need to put hat here. So the in the end, your formula is like n I square. So m can go outside, ni minus 1, and then apply this di bar. Sorry, y bar I minus p hat xi bar square. So that's exactly what we have here. That's what we had here. So basically my point is that the variance of t hat d is square ni 1 over ni minus 1 I equal to 1 to ni mi no I m square y bar I minus p hat x bar I square, and then the variance of p hat equal 1 over t hat x square variance of t hat d. So that's basically, you note that t hat x, what is t hat x? Is a total estimator. So you have right. So if you plug in and apply, you have actually this guy cancels to here. If you think of this mi, because of the square, so you end up getting 1 over ni times summation of x bar I square, and then you have ni 1 minus ni minus 1 times I minus p hat x bar I square. So that's the formula here we have. Okay.